Now let's derive an expression for gravitational potential energy. Alright. Now see, look at the figure. We have Earth. Now let's say the mass of the Earth is me and radius of the Earth is re. Now see, we'll consider a point P at a distance of r from the center. Now see, the mass of that has to be very small compared to the mass of Earth. So we'll consider the mass of that particle as m, or that body as m. See, next point is, see, we are moving that object, correct? Let's say x is the distance what we are moving. See, x is the distance from the center of the Earth, right? Now the force of attraction, the gravitational force or Newton's law, what we have is F is equal to G me into m divided by x square. Now this is the force of attraction, right? Now see, force of attraction meaning that body is always pulled towards Earth, correct? So if you are working against the gravity, you have to work. So that work is stored as potential energy, correct? Now how much of work do we have to do? See, we have to have a very small displacement, like from, let's say, 1 millimeter, something like that, very small displacement. Now we have the mass of the particle or the mass of the body as m, and we are moving that by a very small distance. Let's call the distance as dx. See, this is dx. Fair enough? Now the work done was what? Force into displacement, remember? So here, for a very small displacement, very small work will be done. So let's call the small work done as dw. So we get dw is equal to F into dx, force into displacement. Fine. dw is small work, dx is small displacement. So what we get is, we have dw is equal to F dx or G me into m by x square into dx, right? So in place of f we are substituting. See, what we are doing, we are getting that object from infinity to that point P, correct? From infinity to that point. So for every dx distance, I am doing dw work done. So for every displacement, I am doing small work. So how do we get to know what is the total work done? Now here we integrate. See, integrate meaning what? To sum up things. Like the normal English meaning, integrate meaning summing up, correct? So we integrate this formula and then we get the total work done. Fine. So let's see how the integration goes. Fine. So we have W is equal to integration from infinity to R G me into m by x square into dx. Okay, so let me just tell you what is this particular symbol and R infinity and all those things. See, when you're integrating, we always have something called as limits. So limit is basically from which point to which point we are going. Now we start at infinity and we go to that point, correct? That's how we calculate the potential. So R is called as the upper limit, infinity is called as the lower limit. Fine. So here, see, look at that, dx is there and x square is there, right? Now G, me and m are constants. So we can take it outside the integral sign. So we have G me into m integral from r to infinity x to the power of minus 2 dx. Fine. So when we integrate this, we get this as G me into m into x power minus 1 divided by minus 1 from r to infinity. Now we get minus G me into m into 1 by x from r to infinity. Now we have to put these values, we need to substitute it. So we get minus G me into m into 1 by r minus 1 by infinity. Now 1 by infinity becomes 0. So we have the work done as minus G me into m divided by r. This work done gets stored as potential energy. So we have U is equal to minus G me into m divided by r. Fine. Now this formula we use when the height of the object is very less compared to the size of the radius of Earth. Fine. Now if the height is comparable to the radius of Earth, then we have another formula. Okay, u is equal to minus g me into m divided by re plus h. Okay, now the formula changes. So remember, these are the two formula for the gravitational potential energy. So one is u is equal to minus g me into m by r. The next one is u is equal to minus g me into m divided by re plus h. Fine. So remember, we have used a new concept of integration. So make sure you go through this video again so that this sticks to your mind.